All right, so the goal of this video is to look at a few sample problems related to net force. All right, and I'm also going to try to show you a trick that you can use for any math problem that you're given, a strategy that you can always follow to kind of make sure that you're organized and that you're using the numbers correctly. So let's look at this sample problem here. We have Deshawn and Zion work together to push a table to the right. Deshawn pushes with a force of 60 newtons, and Zion pushes with a force of 55 newtons. John pushes the table to the left with a force of 40 newtons. Draw a free body diagram and find the net force. Show your work. All right, so I'm going to start off by drawing a free body diagram, and then I'll try to do the calculation behind it. All right, so we have some kind of object that's being pushed. So in this case, it's a table. Deshawn pushes with a force of 60 newtons, and Zion pushes with a force of 55 newtons. And John pushes with a force of 40 newtons to the left. All right, I'm going to try to make this one just a little bit longer, right? Because we're trying to make our arrows proportional. But that's it. That's our free body diagram. Now, maybe the harder part is finding the net force. So one strategy you can use anytime you're given some kind of math problem is this acronym called GUESS. So this stands for given, what numbers were given to you. What's the unknown? What is the question asking for? The equation that you're going to want to use to solve, you substitute your numbers into the equation, substitute, and then you solve. All right, G-U-E-S-S, guess. All right, so the givens. We were given a few different forces. I'm just going to kind of number these. So force 1, force 2, force 3. So we have 60 newtons, we have 55 newtons, and we have negative 40 newtons. Now the negative comes from the fact that we were pushing to the left, or John was pushing to the left. So because it's to the left, we treat it as a negative. All right, so those were our knowns, or what we call our given, the numbers that were given to us in the problem. The unknown, what is the question asking us for? Well, it's asking us for the net force. So that's our unknown. And now we need to think about what equation can we use to find the net force. And so in your guided notes, you might see something that looks like this. The net force is equal to F1 plus F2 plus F3, dot, 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 dot. No matter how many forces you have, the net force is the sum of all the forces. You're going to add up all the forces. So that is our equation. Now we're going to substitute. We're going to substitute our numbers in for all these, for some of these symbols here, or some of these variables. So net force is going to be equal to, well, I have 60 plus 55 plus, a little bit tricky here, negative 40. Again, that negative 40 is because John is pushing to the left. And one thing you'll see is when you're adding a negative, that's the same as subtraction. I mean, you could have easily written this as 60 plus 55 minus 40. All right, these are the same. Also, another fun fact, it doesn't matter which order you go in. You could have done 55 plus 60 minus 40. You could have done 55 minus 40 plus 60. That's, I think in math we call that like a commutative property, where it doesn't really matter which order you go in. Anyways, so you can do this in your head or you can do it in a calculator. This is going to come out to 75 newtons. All right, and that's it. So again, we looked at the givens. What numbers were we given? We thought about what was the question asking for? What was our unknown? And then sometimes the hardest part is thinking about what equation do I use? But once you know the equation, you substitute your numbers in and then you solve. And that's a pretty surefire way to solve any problem that you're given in physics. Not just a net force problem, but any problem I give you, this is a good way to go about it. All right, let's do maybe one more real quick. So let's talk about one where you might have a net force in both the x and the y direction. So a box is pushed, has 4 different directions, has 90 newtons north, 40 newtons south, 50 newtons east, and 30 newtons west. Draw a free body diagram, find the net force. So once again, I'm going to start with my free body diagram to kind of help me visualize what does this look like. So 90 to the north, 40 to the south, let's see, 50 to the east, 30 to the west. Okay. All right. So again, using our acronym from before, our givens, so we have F north is equal to 90, F south is equal to negative 40, force to the east is 50, and the force to the west is negative 30. Again, south and anything going down is considered negative, west and anything going to the left is considered negative. All right, so one tricky part here is you cannot combine forces in the x and y direction. Right? We have to treat those as separate. So what we're going to have here is we're going to have two net forces. We're going to have a net force. Let's see, we'll call this one F net x, and then we'll call the other one F net y. All right, but these are the unknowns. These are what we're trying to find. We're trying to find those net forces. All right, so again, the equation that we use is just like the one from before of our net force is just adding up the forces. All right, so for the x direction, we only want to add up the forces in the x direction, like east and west. So that would be F of east plus F of west. All right, from here, I'm going to substitute some numbers in. So 50 newtons for east, and then 30 newtons, negative 30 newtons for west. All right, and that's going to come out to 20 newtons. All right, so we looked at our knowns, we looked at the unknown, we thought about what equation we're going to have to use, we substituted our numbers, and then we solved. Same thing for the y direction. We're going to do north plus south. That's going to be 90 plus a negative 40. And that's going to come out to 50 newtons. All right, and that's it. You can stop there. There might be some more complicated problems that I give you as an Aspire activity where you might want to use a little bit of vector analysis, fancy word, to figure out what is the overall net force on this object. But for now, this is good. If I ask for net force in x direction and net force in y direction, this is exactly how I would try to answer the question. All right, I hope this was useful, and I hope you have good luck on your problems that you're working on.